Hey everybody, we're going to go ahead and start taking our notes on section 4.6, which is the graphs of other trig functions. So the other, since we've already learned sine, which I didn't write that correctly, we've already learned sine and cosine. Recall that the other ones are tangent, cosecant, secant, and cotangent. So that's what we're going to learn how to do today. But we are not going to learn damping factor. We're just going to be learning the other four trig functions. So when we're talking about the tangent function, so remember tangent is the same as sine divided by cosine, so keep that in mind. So the graph of y equals tangent is symmetric with the respect to the origin, and that's because it's odd. The period of the tangent function is pi. So this is different than sine and cosine. Again, the period for sine and cosine is normally 2 pi. We've been talking a lot about that. But this is just pi for tangent. So this is really important that you remember that, okay? The tangent function has something called vertical asymptotes, which we'll talk about what that looks like at every increment of pi over 2 plus pi n. That just means as n increases and decreases in negative and positive values, every time you go a distance of pi over 2, that's the period of pi. The domain of the tangent function is all values of x as long as x is not pi over 2 plus pi n, which is also the asymptotes, right? And then the range of the tangent function goes from negative infinity to infinity because it goes straight up and down and side to side. So really quickly, just keep in mind, this is how we're going to graph tangent. So setting up the x-axis is a lot like setting it up when we were setting up the axes for graphing sine and cosine. Okay, so this is our x-axis, this is our y-axis. Now keep in mind, tangent is sine divided by cosine. So that means every time that the value of sine is 0, so is tangent. And every time that the cosine is 0, tangent is undefined. So we talked about these asymptotes here. Remember, that just means it's also where cosine equals 0. So we know that because our asymptotes are at pi over 2, so every time we hit pi over 2, that's here and here. So we go pi over 2, you add another pi over 2, it's right this way. So pi over 2 plus pi, which is the period, plus another pi would be another period. So if this is negative pi over 2, you'll have another asymptote back here. So with that said, now we can talk about, okay, where are the x-intercepts? We didn't talk about that in the notes yet, but the x-intercepts are going to be where the sign is 0. We know sine is 0, at pi, and 2 pi. And if you recall, in our cute little, 1, 2, 3, 3, 2, 1 box, at 45 degrees, tangent was a value of 1 if we filled in that box. So at every increment of 45 degrees, that value is at 1. So if this is pi over 2, here's pi over 4, and that value is going to be 1 here. So basically, right to the pi over 4 to the right of where the 0 is, you're going to plot those values of 1. And this is what the graph is going to look like. It's going to bend and kind of make half of a U to the right. And then it's going to reflect down because it's reflective over the origin. And at negative 45 degrees, it's at negative 1, and it looks like this. So we bend like a half a U up to the right, and then we flip the other half of the U down to the left. Okay, so this is super important. You need to know first where the asymptotes are. And we know asymptotes are at pi over 2, and then they're pi apart. And then every time we have a 0, they're pi apart as well. Tangent goes up to the right and down to the left. And then keep in mind when we're sketching the graph of a function in this form, remember A changes the amplitude, which is going to look a little different on tangent. it means that it will bend a little differently. And then remember, B will change the period. So the period for tangent is pi. So then you're going to multiply it by whatever 1 over B is. And then again, C is your phase shift, just like sine and cosine, and it's C over B. Okay? So let's talk about cotangent. So the cotangent period is the same as tangent, because remember, cotangent and tangent are reciprocals of each other. So we know the period of cotangent is pi. The domain of cotangent is all values as long as x is not equal to pi n. And that's because its asymptotes are at pi n. And the range is from negative pi to pi. So the vertical asymptotes where the cotangent occurs is the same places where the domain isn't existing. So we say x equals pi n. And when we graph that, let me just show you how to graph that here. So we're going to set up our x and our y axis just like we've been doing. Here's 2 pi, here's pi, pi over 2, 3 pi over 2, here's 1, and here's negative 1. Keep in mind that cotangent is the reciprocal of tangent, or you can say that it's cosine over sine. So just keep in mind cotangent is going to be 0 where cosine is 0, and cotangent is going to be undefined where sine is 0. So let's talk about where sine is 0. Well, sine is 0, that's really easy to remember when at this point right here. Well, I happen to know if sine is 0, that makes cotangent undefined. So you're going to have your asymptotes right there. And then because the period of cotangent is also pi, every time we add pi, we're going to have another asymptote. So there's my asymptotes. And now I'm going to go ahead and graph those zeros. And I know whenever cosine is 0, so is cotangent. So cosine is 0 at pi over 2 and 3 pi over 2. And then if you look at those values, remember that cotangent is just going to go down to the right because they're reciprocal functions, or the opposite values of tangent, reciprocal values of tangent, and then it goes up to the left. So it's a different shape. They're almost symmetrical to tangent. It's the same look, but instead of going up to the right like tangent, it goes down to the right. Instead of going down to the left like tangent, it goes up to the left. Okay, so make sure that you have this parent function for cotangent in your notes as well. Okay, so then let's talk about the rest of our reciprocal functions. Remember that cosecant of x is a reciprocal coordinate function of sine x, and it's also symmetric with respect to the origin. Okay, the period is again 2 pi, and it has vertical asymptotes at pi n, which just means every increment of pi, there's an asymptote there. We know the domain of the function is all values of x except for where the asymptotes are at pi n. And the range of the cosecant, it goes from 0 to negative 1, and then again from negative 1 to positive infinity. So let's talk about what that looks like. So we're going to show you how to graph that. So we're ending at 2 pi here. Here's pi over 2. Here's 3 pi over 2, and just for good measure, I'm going to put negative pi over 2 here. This is our y-axis, and here's our x-axis. So remember we talked about where the asymptotes are. We know the asymptotes are at x equals pi n. So every increment of pi, we've got an asymptote. So here's an asymptote. Here's another asymptote, and here's another asymptote. And that's because if cosecant is the same as 1 over sine, every time that sine equals 0, we're going to have an asymptote. So just think about that. Every time sine equals 0, there's an asymptote. Okay? And then with that said, whatever value of sine as we go across right here, So if I'm just gonna go ahead and graph the parent function, which is sine, okay? So remember, sine looks like this, okay? So I'm gonna use that to graph my cosecant. So even if there's transformations of that, this is how I'm gonna do it. So I'm looking at my sine function, which I'm gonna write that in green here, y equals sine. And in blue, I'm going to go back over, and I know every time there's a 0. So here's a 0, here's a 0, here's a 0. We draw on those asymptotes, which I kind of jumped the gun earlier. I drew them first, sorry. Now I'm going to look at the peaks and the valleys. This value here, sine is 1. Well, the reciprocal of 1 is 1. But see how this value here, the sine is about a half? What's the reciprocal of a half? Well, it's up here at 2. So we can see that this is going to look like it's going to kind of bounce. It's almost like there's a mirror, and it's bouncing this shape off right here, and it's making a U right there, okay? At 0, again, we know there's an asymptote through there because we know 1 over 0 is undefined. At this point right here at -1, the reciprocal is still -1, and then it's going to bounce down. So this blue graph, this graph right here, is the y equals cosecant graph, okay? All right, let's talk about secant now. It says the y coordinate, or the secant, is the reciprocal graph of cosine x. It's symmetric with respect to the y-axis, and its period is 2 pi, just like cosine. It has vertical asymptotes at pi over 2 plus pi n, so every pi over 2, and then you add pi to that. And then that means the domain is where the asymptotes are not. So all values of x except for pi over 2 plus pi n. And the range of the secant function is between -infinity to -1 and from 1 to infinity. So let's go ahead and graph this one as well. So again, I'm going to set this up just as if I was going to graph cosine right here. So here's 2 pi, here's pi over 2, 3 pi over 2. Here's 1, here's -1. So by now, I'm really hoping that you are really good at graphing sine and cosine. So cosine starts at 1, and we go down, down, up, up. And then we're going to use that, and we're going to start to look at, okay, if cosine equals 0, that means its reciprocal will be undefined where it equals 0. So we see it equals 0 here and here, which means the secant function, y equals the secant function, is going to be undefined at those values. And that's where you're going to see your asymptotes. Now let's look at the peaks and the valleys. We know the reciprocal of 1 is 1, and so it's going to kind of mirror that shape on top of itself. It's going to reflect it down. The reciprocal of -1 is -1, so then it reflects down this way as well. So in red is that graph of secant x. I want you to get really, really good at being able to graph these parent functions of sine of cosine, and then graphing their reciprocal functions as well. So graph those functions of sine and cosine depending on what you're graphing. Find your asymptotes where the values of 0 are. Find your peaks and valleys and make those reciprocals. Okay. So how do you graph secant or cosine secant function? First, you're going to graph either the cosecant function if you're graphing secant, or you're going to graph the sine function if you're graphing cosecant. You're going to find from there your asymptotes, and you're going to graph those reciprocal values. Okay. And then we're not going to worry about this, and we're not going to worry about this, so I will see you back in class.